Good afternoon, everyone. Welcome to the results of the student track. I've seen so many good things today, so I would like to have a prior to the presentation already an applause for all the students attending. Thank you very much. Lloyd, James and I were in the jury. We had discussions about the result, and James will now announce the result together with some motivation.
Oh man. So okay, let's start with this. I say this every year at these things. This is my favorite part of this entire event, the student track. It is the coolest thing, just seeing all that gets done by a group of people who have never touched fire before getting involved, and all that gets accomplished over the course of a tiny bit of time, on top of coursework, on top of everything else we know you're doing. It is super cool. So, I mean, first off, congratulations every one of the teams. You guys did awesome. And of course, as with every year, it's a tough decision, and we spent ages agonizing over it. So the 2017 winner for DevDays, drum roll please, is the team from Cologne. Come on up and grab your trophy. So to everyone else in the hacking space, I know you can hear me. We are going to have a presentation by the winning team, and what they did is really cool. I'd like to encourage everyone to make their way over this way and come and watch in a little bit.
Yeah, thank you very much. We're glad to be here. I think I don't know any faces here, but still pretty awesome. Yeah, don't have very much to say. Thank you very much.
Nice. It is.
And we're presenting because we're way too big of a team. We're going to present what we did for this year's FIRE conference. We're going to talk about how we use the FIRE standard in order to navigate complex medical data. The presentation contains the following points. First, we're going to make proper introductions, say who we are, where we came from, what our project actually was. Then we're going to talk about which use cases we chose to focus on. Of course, we all know there are more than a million actually potential use cases that we can talk about. We only chose 2 that we actually focused. And then we're going to say how we approach these 2 use cases in order to maybe improve the situation in them. Next, we're going to show a live demo of what we think is a really awesome implementation. and also talk about the architecture of the application and the server that we used, that we implemented, and last but not least, the difficulties that we encountered for this year and what we learned. Okay, so here we go.
Yeah, as you've seen before, beside me and Theodora, our team consists of 6 people. We have done the project at the University of Applied Science of Cologne, in cooperation with a consulting company in Cologne named Lexion AG. And I think not much to say more about the team. So we skip to the use cases. We come to the first use case. We just thought about what could be possible problems, and to mind came that in Germany you often come into a doctor's office, and the assistant is sitting there with tons of papers and searching for your appointment, searching for your data. Therefore, we thought that should possibly be an easier solution. Also, the systems they're working with often have many input fields, many fields to assign data into. So we thought, how could we possibly make it easier? Thought about a possible solution for that. And also, the second use case is in the personal conversation with the doctor, the consultation. The doctor often has to search data for you from maybe different other doctors you went before or from their system, gather the data, ask you questions, gather more data. Yeah, and Theodora will now present how we thought what might be a possible solution to solve the problem.
Okay, so based on these 2 use cases, we started like good, hopefully good little interaction designers, and we started with the users. So we thought about what the user would want, how to make everything as intuitive for the user as possible, be it doctors, patients, or nurses, administrative people, whatever. And we thought about using natural language processing in order to give them the data that they want without having them have to think too much about which entities they actually need and which attributes they actually need from them. So we thought they could talk with with an application which would analyze their speech, be it on mobile or desktop devices. This application would then analyze their sentence and translate it into a FHIR encoded URL, so a standard FHIR URL, which would then be sent to the server. This server could communicate with any necessary databases in order to retrieve the data, encode it in FHIR, back to the user. So our principal point was to make it as easy for the user as possible to get the data that they want without having to navigate anything visually. So just asking for the data that they need, kind of like Alexa. So now we're coming to the demo part. Hopefully this can be presented too. Hi. Okay, so we start out with a FHIR application. Oh, maybe. Can everybody see it? Yeah. Okay. And let's say we're searching for appointments because we mentioned that it's quite difficult to search through paper work for an appointment. Show me all appointments scheduled for the 2nd of February 2017 for the practitioner named Ronald. Okay, let's see if that worked. Yeah, there we go. So we have our sentence. We can see that the entity. Thank you. So there we have our entities, appointments, and practitioners. We used user-friendly colors, which you can't see on the beamer very well, but our attributes are green. And then the attribute, and look at that. Ronald wasn't found, so let's add him. So we have here for practitioner just name and ID for now. And let's say the operation would be contains and then value Ronald. Okay, now if we send a request, we're sending it to our own server, and we get a very Spartan detail view with the information of the appointment. So we have Dr. Ronald Hart, doctor's office number 2, patient is Adam Appleseed, the time isn't formatted yet, but it's from 9 o'clock to 9:30, and so on. And because we're all developers, we can look at we have a little debug view where we actually see the entire response. As you can see, we only took the first appointment. Dr. Hart actually has 3, but we just decoded the first one. There we go. Okay. We can also do, for example, an interesting thing would be the following thing too. Show me all medication statements which were not taken due to side effects by the patient named Peter. Okay, and here we have the not take. We forgot to mention that in the first presentation. This is an extension that we did for the medication statement entity. And again, it shows directly the medication name, reason not taking notes, and dosage, and so on. Okay, so maybe getting back to the presentation. Maybe. So the first URL was appointment. Another interesting thing that we didn't just search for entities with their attribute values. We also managed to do chaining. So we see here we have appointment and then practitioner named Ronald. And the same for medication statements. We started with the patient name. We have medications with the reason not taken, which is our extension, but also we have patient name containing Peter. So we managed to implement chaining as well. And our system architecture, first of all, we have the mobile application. We're using SF Speech Recognizer in order to understand what the user is saying. Then we built our own little meta model based on the entities that we thought were interesting for these use cases. And based on this meta model, we could identify which entities we had in the sentence, then which attributes appeared, and then finally which attribute values. After all that, we created a URL and sent it to the Fire server.
Yeah, as for the server, we decided that it would not make that much sense to show a terminal, so I will just say that it's a Node.js implementation. We're using Framework Express. I don't know who knows Node.js, but that's a kind of web framework. Working with a CouchDB in the code version 2.1, and an Nginx load balancer to somehow improve performance. Could be left out, but works quite nice. And as for the queries for MongoDB, we used for CouchDB, we used the Mongo queries. That's some kind of HTTP post request, sending a selector to the database via REST API and getting a response in a JSON format. Had some problems with that, but we'll come to that later. My part, so. As for difficulties during the project, I think to start off, from us 6, only one person had a little bit of experience with Fire, the other ones were completely new. So it was a bit hard to get to know the frameworks, to work into the standard, and to get an overview and not just start working and realize, oh, we have done everything wrong and have to repeat from new. Yeah, anywhere else you better say something.
So we also had a different. It was a struggle getting from the entity tree what we built, how to make the URL, because for example we have chaining with the main attribute with the main entity and then the next entity that get chained afterwards. We had to currently it's just with the first entity, which is mentioned gets to be the main entity, but yeah, that was one of the struggles. And this is we found this quite funny because we heard a Google presentation a few hours ago about the use of synonyms. We had the same thing. What if, for example, a user mentions doctors instead of practitioners? We try to cover this as much as possible, but this is actually an issue. When do we stop defining synonyms? We decided to use just relatively usual words, but we only developed this, for example, for the English language. Basically, what we see here is that for each language, a really good meta model or a really good nearest neighbors need to be determined for each type of entity in order to be able to correctly identify entities. We currently have that hard-coded. Yeah.
Yeah, as for the server again, basically CouchDB was the biggest issue or problem at least, because we can't chain in Mongo queries because the selectors are not able to do recursive selections. So the chaining was kind of, yeah, let's say more bigger problem because we had to do it in code and you can't do one request or have to do multiple requests to get the data we need. And also to be mentioned, in 2.1 it should be fixed, but we just upgraded like three or 4 days ago, so we hadn't really time to test it yet. And before, Mongo query, it's a feature, but also a problem that you just get a limited number of results. Even if your search query gives thousands of results, you just get from starting to limit, and you can't estimate how many results you should get if you get everything. But you just get the 25, 40, 60, however you set the limit. So even if you set a limit of, let's say, 1,000, only get 1,001 entry, you still have a problem. In 2.1, CouchDB promised to give a parameter that gives the total length of the results that should be delivered, but we hadn't had time to test it yet, so I think we can fix it in the next weeks, probably.
Yeah, so we had quite a few struggles. Some of them aren't listed here. We had a lot of fun, for example, in the coding session, because we could actually test out our app with different servers, and people could test their apps with our server, and it was pretty easy because everybody used the same standard. So on that note, we hope that this is not going to be the 15th, but the one, and thank you for your time.
Any questions?
So one of the hard parts you seem to have fixed is the whole text-to-speech and then mapping it to a search query. I was a bit surprised that you also put time into actually building a file server. Did you think about using one of the existing ones, or was it part of the project?
Yeah, we technically didn't thought about that because Alexander had made, in his bachelor thesis, also already implemented some kind of server up to a defined limit. I don't know what exactly it was supporting before. I think he can say more about that.
Yeah, it was like a test how difficult it is to build a server, and we just wanted to try that out. Well, for the most part, it worked quite well. The basic update create operations were really quickly implemented, but the search was a bit of a struggle. And the chaining and all this is, you have to wrap your mind around it.
I don't think we will finish yet with the whole search. We definitely have left out parts, but I think it's a good start. It's kind of a nice feeling to have the survey implemented ourselves, even if we could use the default one. Any more?
Okay, the question was if we hard-coded operators for the attribute values, or if we somehow dynamically made them. Yeah. So our meta model consisted of entities, then which attributes these entities have, and then which attribute types these entities have. And then for attribute types, for example, strings, we took the possible fire operators, contains, exact, and equals. For date, we took the entire less than whatever. And then we scanned the part of the sentence which might possibly have contained an attribute value. We knew if it was, for example, we knew what type of data, what type of attribute it was. So, for example, a data or a string. And then, if it contained a negator, we knew that it was not. If it contained some keywords, it was probably, for example, exactly. Then definitely it was exactly. But we did it dynamically. So there probably are some ways to trick it, but we try to do it as dynamically as possible. So I can say, for example, since today or before today, and this can also be recognized. The question was if it works with any resource. Yeah, so we only had the strings, dates, and whatever, but yes, we also only considered the